We're now ready to use our understanding of rises and runs to combine those into understanding what we call the slope of a line. The slope of a line gives us a number that tells us how steep a line is. How steep a line is. So the equation for slope is that slope is equal to rise over run, or rise divided by run. So here we have a line, and we're asked to determine the slope of the line as a fraction and as a decimal. So to start with, we have to be able to count a rise and a run. So I'm going to pick a couple of convenient points where the line lands nicely on the grid. So I'm thinking these 2 points. These will be very easy for me to count a rise and run. So what's the rise and what's the run? Well, the rise is between 2 and 5, so I could use subtraction, or I could just do this in my head. Between 2 and 5 is a rise of 3. And the run is between x equals 1, so there, and x equals 5. So the run between 1 and 5 is 4. So the slope, which is equal to rise over run, is going to be equal to 3 over 4. Here's my answer as a decimal, or sorry, as a fraction. And if I wanted to change that fraction answer into a decimal, I would just have to do the division either in my head or with my calculator. 3 divided by 4 in my calculator, I get is 0.75. So that's the slope as a fraction and as a decimal. Let's do one more example. Determine the slope of this line as a fraction as a decimal. And it looks like we're given the points already, which is very helpful. And you'll remember that points are given as a pair of x and y values. So this is x comma y and x comma y. So what's the rise between those 2 points? Well, the rise looks like it's actually, instead of being a rise, it's actually a fall or a drop. And one way to calculate that is, again, let's do the y value. The later y value is 4, and subtract away the earlier y value, which was 7. That's negative 3. The rise is negative 3, or you can think of it as a drop of 3. The run is going from 0 to 4, which is 4. So the slope is going to be equal to rise over run, negative 3 over 4. And if we did this in our calculator, again, we'd get, this time, negative 0.75. So we've seen now that slopes can be positive if they're increasing or negative if they're decreasing. So one of the things we want to be able to do is recognize just by the slope shape whether it's positive or negative. So a positive slope increases. So there's an example of a positive slope. Reading from left to right, it's going up. A negative slope decreases. So it'll look something like that. Between a positive and negative is a zero slope, which is just a flat line. Basically what that means is that the slope, which is rise over run, that there's 0 rise over the run. So it's a 0 slope. And then there's also vertical slopes, which we will not see very often at all. But that might happen if something like there's a really explosive change in some y value. As we're describing slopes, we'll also find that slopes can be very steep or very shallow, or somewhere in between. So an example of what might be a steep slope is a line like that. It goes up very high very quickly. And an example of a very shallow slope might be something like this, which is that it takes a very long time to increase much vertically.